So in the last section, looked at linear regression, and what we had was one variable that allowed us to help determine what a grade would be. So that variable was study time. So in that example, we said for each hour of study time, there would be a output, a certain amount of an addition to your grade, right? So our y-axis gave us a baseline, and then each hour of study time would move it along the diagonal line up. So what if we have more than one variable? We have to use what's called multiple regression analysis. So in this example, we're going to continue on with our last example. We decide to add another variable to our model, the number of classes attended. Construct a multiple regression equation based on the observation. If someone studies 4 hours and attends 6 classes, predict the grade they would get. So again, what we're looking for is that diagonal line that would allow us to make a model that we can use to predict grades. Now for multiple regression, it's very complicated, so we use Microsoft Excel. So I've entered in here. I've copied this over from our example, but sometimes you may have to create a chart. And you can go to Data and Data Analysis. Go to Regression and OK. And now we want to input our Y range. So our Y range would be our grade percentage, right? This is what we're trying to determine. Remember, our formula is our y equals a plus bx, b2x, b3x. That would be what it would be. So our y-axis is sort of what is our baseline. So what is our grade? What are we trying to determine? We're trying to determine the grades. Our x range would be our variables. So now we have two variables. So we'd convert this over 2 columns. Now I'm just using the data. If you were to use it all, you would have to put in a label box here. I'm going to set it out to a new worksheet. And I am curious in residuals. So we press our residuals. We'll talk about those in a moment. And up pops our chart. I'm just going to change these to have just 2 decimals just to see at a glance. Okay, everything has 2 decimals. Let's have a look at what we end up with. So we have our regression statistics. So this is all the work that we've done over the last couple of sections. Right there in about a span of a 10-second click. We have our ANOVA table, which again, in about a 10-second click, will allow us to determine our ANOVA. And we have our intercept and our 2 variables. So we can start here and set up our formula. So our formula, y prime equals a plus b1 multiplied by x1 plus b2 by x2. Now this would continue on if we had more than 1 variable. In this scenario, or more than 2 variables. In this scenario, we have 2 variables. So y equals a, which is our intercept, 35.59, plus b1, which is our first variable. As you can see, we've had our first one was study time in hours, which we set on the left, 2.79. Times, we want to know the 4 hours of study, plus our second variable, 48.4, it's got a coefficient, and we have said that there would be 6 classes attended. So the great thing about this multiple regression analysis is that it will set factors based on the information it gives. So as you can see, it's more important to attend classes than it is to study in this scenario based on the data. So when we complete this, we get a total of 75.79. So if a student studies 4 hours and attends 6 classes, we can predict that they would get a 75.79% on the grade based on our observations that we've already calculated. Just want to quickly review what our residual output is, because we can follow what's called the least squared method, which reduces the residual as much as we can. So here on observation 1, y would have predicted 53.63. Now we have a negative 0.63 amount. We see here that there is a 52 actual grade. So we would have predicted 53.63, but they actually got 52, which means there is a difference of negative 1.63. That's what our residuals are. So often the least squared method would try to remove our residuals as much as possible. Now that's bound to happen. If we have a look at our linear regression model, if we consider each one of these, so here's the y-axis, here's the x-axis, each one of these would be our observations. As you can see, our linear regression model is going to give us a model that follows this straight line. But in reality, there are very few observations that will ever fall exactly along that line. There are a couple, but for the most part, we're following a trend. We're trying to create a model that gives us the trend. So each one of these would have residual. This one and this one, for instance, would have a higher residual than, say, this one and this one. And that is sort of how the system works. That's sort of how the model runs. So we're going to be using this table here over the next few questions to show you a couple more things.